It is horrible, but it's not swearing. Don't worry about it. Only hardest language in the world. Okay, so this is our language, that S. And we're going to use that language to write our program. All right? So now, as you remember, 3 will be our program, which will be built on our language. And this is a really pretty neat idea here, because now you see that our program will be constrained only by those 2 verbs, print line or get line. That's all we will be able to do, nothing else. No possibility to launch a nuclear attack or send your email to your mom, because the only things that you can do is either print line or get line. So now we get to, so we will write now two methods, which will give us a program, and the simple program, one which actually gets a line, and the second one which prints a line. And we get those lift f methods from Scala Z for free. So what they do is they take our language, in this particular example, print line, and then they lift them into a program. Okay? Don't worry about it how it works. You just need to really think about that they give us this ability to change those structures into programs. Okay? So now 3 is a monad. So now if I want to write a program that will ask for my name, then get line, and then it will print my name, hello, it's nice to meet you, I will be just reusing. So print line, as you remember, is a 3 that will represent a program that just prints the line whatever you gave it to him, right? Get line is a program that the only thing that it's doing is fetching the line from the console, okay? So, but now we have those 2 little programs, but we can construct something more complex by composing those programs together. And we do it using for comprehension. Make sense? Okay? So now we have a program. And so now we have a program based on the language. Let's try to run it. So we run our application and nothing happens. Why that is? Because this is still just a program. As you guys remember, if you want to write if you have a program, in order to run it, you have to compile it or interpret it, right? We need an interpreter. We need somebody who will tell us what does it mean to print line. What does it mean to actually fetch a line from a console? So we can, here, we are creating that interpreter. And this interpreter is something we call natural transformation. That natural, so this thing here, a natural transformation is not really a scary concept, because what it really is, when you see this natural transformation from f to g, only thing it's just a function that takes f of a and it will give us a g of a. Okay? So from f to g is nothing else as a function. I will go from f of a to g of a. So here we have a natural transformation from input-output to task. So what it really is, it's a function from input-output a to task of a. Okay? That's really what it is. So I'm saying where if I'm printing a line, right? Then and print line is input-output of unit. It will give me a task which will be actually printing line on the console. And I have another case where actually somebody asks me for a line. That it means I will give you a task that will fetch that line from the console. That's our interpreter. Okay? It's just telling us what should happen if we encounter print line. What should we do if we encounter get line? So now, having this program and our interpreter, we can finally run our program. And we do this by calling program fold map, and we provide the interpreter, which will give us, as a result, a task of unit, right? Because we are interpreting from our algebra to task. If our interpreter was from input-output to something else, to foo, we would get in result foo, right? Why unit? Because our final program is returning a unit, right? It's not really producing any value. It could produce like name or something, but in this example, it's just producing a unit. Okay, so far so good. If we actually run it, we get a running application. What is your name? My name is Pawel. Nice to meet you, Pawel. For me, that's just like Turbo Pascal all over again, back in the 90s. But so if we were able to do just that, that would be really, really nice just to have this little feature. I mean, if you think about it, it is kind of nice, because with this ability, you have now a reason to previously, if I had a method that just gave me a task of a line, right? Or I would say print line would just be a task of unit. I don't really know if that's actually all it's doing, right? I still have to inspect the body of the method, still has to reason about what it's actually doing to be safe to actually call it. Here, I know this program is limited only on this algebra. That's the only thing that it's capable of doing. And if I have the interpreter, I know the final thing that will actually run will only do those two things: get line and print line. All right, but let's look at something. Okay, so one additional thing is tests. Now, if you would like to test this kind of solution, like for this one that we have over here, if you think about it, like normally if you didn't use free, let's say you use task, you have a problem, right? Because how will you test a program that communicates with console? It's kind of really hard actually to test it if you think about it, right? You will have to do a little bit of magic, workarounds. Those are doable, but that will be really, really nice. If I'm testing my program right now, I can do something different. I can provide, for my tests, I can provide a different interpreter. I'm providing right now interpreter that will go from input output to ID. As you guys remember, ID is just that value. Type IDA is just A. So my interpreter that I only have within tests take as arguments two things: a stack for input and a stack for output. So and it's basically pretty simple. If somebody asks me to print a line, I will push into the output, into this list buffer, I will push that line, right? And if somebody asks me for input, I will just pop a value from a stack. This is just a different interpreter, while the program stays exactly the same. I didn't do anything to the original program. I just implementing a different interpreter for my tests. So now I instantiate those two values. So input will be a stack with one value, Pawel, and output will be a list buffer, which will be empty. And now if I run my program with that interpreter, with those two mutable data structures, what I have to assert at the very end are two things. Was the whole input read? Is the stack empty? 0, yes. And also what I see on the output. And what I see on the output is, what is your name? Nice to meet you, Pawel. Testability, if you can do it easier, do it. Because for me, that's just brilliant, right? Especially if you have functionality that talks to Cassandra or like some external systems, it's really hard to interpret that. This is just awesome. Okay, but that wouldn't be enough in order for me to actually be so excited about free. Is that really important? Logging. So let's talk about right now about other algebra. Logging. Okay. So like info, warning, error, something you would like to have within your system. So I have another set of algebra: info, warn, error, debug. And one more time, I can lift those values from my language. I can one more time lift them to my program, and I can one more time provide interpreter of what should happen if you encounter info, error, warn, or debug. Right? I'm using log4j, but you can use anything else you use for logging. One more time, I'm just saying I'm giving you a language. I'm giving you ability to write programs with that language, and I'm giving you an interpreter. In this example, this interpreter will go from logging to task. Okay, makes sense? And now if I could write a program, right? That's a very simple program. It will just put something to info and put something to debug, and then I run this program, which gives me a task, and I run this task, and we have a solution: info and debug. Awesome. But now the question is, can we do both? Because that would be really, really cool if you think about it. Let's think about it for a second. Like when Runar was making a talk about free monad, he made a very good, back in I think 2012, he made a very good example, a user story. As a user who has a right to send money, I want to send money from one account to another. A user story, like typical business user story that you have in your application. If you think about it, the user story is composed of two different concerns. One thing is sending money, right? Actual physical work of pushing the money over the wire. A different thing, completely different thing, is authentication. Those two should be probably decoupled from each other. Wouldn't it be nice if we could have an algebra here that would just represent the verbs, what it means to send money? Like all the verbs that actually your business is using when they talk about sending money between two accounts. And you can then write your programs, and you can write your interpreters. You can do integration testing with your interpreters. Whatever you want to do to be sure that this module, this money sending thing works. And then you have another concern, which is authentication, right? That would be cool if we could just talk about authentication without sending money, or talk about sending money without authentication. I can reason about it, test it, I know it works. And then finally our user story could just combine those together. That would be nice, right? And this is this example. So can we do both? Could we actually write a program that would be using both logging and input and output? Well, the question would be, what would be the language of that program? What would be the language if we want to do both? Some kind of sum, right? It would be nice if we could just say there would be some type EFF, and it would be a sum of input, output, plus logging, right? That would be nice. And we have in Scala Z something which is called, whenever in category theory they talk about sums of types, they talk about really about coproducts. So if you hear the funny word coproduct, think sum, because that's what it really is. So we are creating a type which is called coproduct, which is nothing else than just summing those two algebras together. So now we created a little bit more complex language, okay? In order to implement this, we will have to do a little trick here, because our methods getLine and println, they were always only using the language input-output, right? That's the language that we're using. But here we have another language. We have language EFF. So we won't be able to get free of EFF, because our utility functions give us the programs that only use this input-output language. So we do have to do something about it. And what we do, sorry for that. What we do, we make a little change here. So that change is as follows. Okay, and it will look scary, but it really isn't. So now our programs println and getLine will return they still return free, but they return free of some language S. It's no longer input and output, it's some S. While it's not, so this S over here, this here S here is that S over here. But it's not any S. It's an S that you can, where input, output, and we say it's injectable into S. And what that really means, and I could go into details and show you Scala Z code, but we don't have time for it because we only have 35 minutes. So just take my word for it, okay? When input, output is injectable into S, what it means is that that S is either input, output, so it means that S is basically input, output, or S is a coproduct when one of the algebras in that of the types in that coproduct is input, output. So it's either two of those, okay? Either input, output, or coproduct, where input, output is one of the elements within the coproduct. And obviously, if you have a coproduct, like if you want to compose three types together, you obviously can do like a coproduct of a coproduct and a type. So it's still doable. So now, and everything else stays exactly the same. The interpreter is exactly the same. Our programs and all that will stay exactly the same. So it's only that S is different. And we will have to do exactly the same thing for logging. It's no longer that we are using a logging algebra, we use S. But we have an evidence that S is that the logging is injectable into S. Okay? And that's the only thing. So now we can actually, and yeah, I'm just showing that it still works with logging. Okay? So I can still parameterize this by logging, so that thing over here is that S. I can still say it's basically logging and the whole thing will work. But now let's go back to our example. So now we can actually write, maybe I will just show you one thing which I skipped. So all those functions, the helper functions are now closed over a class ops, like operations, right? So all those are closed within that class, and we will have that class in implicit scope. So right now, we just say we have operations for I/O, we have operations for logging. They all both work on some type S, right? We don't know at this. We are still very generic. So I had that question, like, why would I would like to be generic when I'm actually writing a production like business code? This is why you want to be, because I'm still not. I could just say work with EFF. I can write my program and say just be EFF, but I don't really have to do it at this point. I'm only saying that it has to be some language S, and I'm constraining my language S with those two constraints. As you remember, one was saying S has to input output has to be injectable into S, and the other one was saying logging has to be injectable into S. Which and we can write a for comprehension. So I will input something to info like program started. I will ask for a name. What is your name? And I will debug the name was name, right? And I will retain the name as a value. Can I run my program with EFF? Can I? I can, right? Because S is constraining me. I have to have ability to inject input output, and also need have ability to inject logging, which EFF is has its capabilities because it's a coproduct of actually both those two things. So it's fine. So now if I have it, this all works. Now the question is, how would I write? I need an interpreter that would go from EFF to task, right? I still need to somehow execute my program. If I were to write my interpreter one more time for all those coproducts, that would be crazy. So fortunately, I don't have to do this. I can take existing interpreters and I can sum them together. So this is the interpreter that was going from input output to task. This is the interpreter that just went from logging to task. So if I want to have interpreter that will go from EFF to task, I can sum them together, and the whole thing works. This was a kitty for like when I was doing this talk on the conference. There was supposed to be a moment for you guys to relax. We don't have time for relax. So next slide. So is that a cool idea? It seems nice, right? It seems like, oh my God, I can actually do stuff with functional programming. But then you see this. So this is manipulate account. This is a new algebra where we have things like create account, where we put some login and age, and that gives us a handler. So handler is just a long, so just like ID for our account. We can update our account. So we provide that handler, and we say like no, age is right now something else. Or we can deactivate account for a given handler. We can delete account, and we can actually also fetch the account, which will give us the option of user account, whatever the user account is. It's like a login, age, and a flag, whether this is active, true, or false. And we are doing the same thing one more time. So we are right now having those little utility functions. So they will take all those things from our language, and they will just give us a program free of S. We are already like able to sum with other types as well. So and we have all that. We could so that's all available here. And now we want to write interpreter. And oh my God, this is not done. This is just a part of interpreter. So what I'm trying to do is I'm trying to go from manipulate account to storage state, where storage state is state T. We didn't cover state T. Of task and some inner state, where inner state is a long and map and a handler. And it's already like, oh my God, my head, give me my Java back, right? But if we really think about that interpreter, what's really like the interesting part is really, I hope I have it, I don't. Okay, interesting part is basically this. Where somebody is calling create an account and gives me some input values like login and age, I just want to add that user account here. That's really all what I'm interested in when I'm looking at this from when I actually try to reason about this code base 3 months later, why I need to fix it when there is a bug, right? And the same goes with update age. Update age. What I really want to do is I want to take existing user and I want to wherever I'm doing this. And I just want to take existing account, And I just want to say, you know, the h is a new value, that a over here that I got. Everything else that you see here is boilerplate, right? Because it's just things that will manipulate state, put things into state, and then deal with tasks and all that. I mean, if you are familiar with Java, you're already familiar with boilerplate. And I get it. But I would reckon that there are better ways to do this, okay? So we already see, like, with input, output, and logging, it was all pretty nice and easy. But if you try to do something a little bit more complex, it's just exploding with all that boilerplate. And the question is, can we do this a little bit better? Because, I mean, okay, so the program will still work, right? Here I have some program that just manipulates the code. I create some value, I update my age, and then I deactivate myself, and I ask for a user, and this is basically what I'm doing. I can still run it, and then, you know, I can run it then with this. What I give is a state, which I run with some initial values like an empty map and 0 to generate IDs. It will work, but you know, I always think, I've once read this motto that you always should program as if the next person who will maintain your code is a psychopath that's, you know, ready to kill you and he knows where you live, right? So I just wouldn't be able to leave that code to the production because, you know. So can we do something about it? Okay, it's just showing it actually works. And here, bless you. And here there's also an example that I'm just still like not solving the problem. I'm just showing that we can still create like a program, like at this point console application, right? I'm using input-output algebra for communicating with console. I'm using manipulate account to actually manipulate account, and I can write a program. What is your login? What is your age? I get those two values, and then I'm using this manipulate account algebra to create account with that name and that age, and finally I fetch the user, which I return. And those are the interpreters. They compose together. It all works, but I'm just saying it's not a really nice way to write software. Yeah, and it's working. So we can actually make it better, and to make it better, I need to introduce a lower level machinery. So what I mean by that, I will provide two new. We will come back to this problem in a minute, but before we do that, let's try to think about two additional algebras. All right, one would be called monotonic sequence. So monotonic sequence has only one verb, which means next, and means give me next value, give me another long, and then next integer, next integer, next integer. That's the only algebra that we get from monotonic sequence. And here there is some interpreter which I wrote, which is not purely functional, just to make the example simpler. But we can see that we have an interpreter that will go from monotonic sequence to ID. So I'll just return a next long. Obviously, there are cases when nanotime will give you the same value if you call it twice. I'm sort of ignoring this in the purpose for this example. But we are just having a monotonic sequence and an interpreter that will know what to do if somebody will ask for a next integer. It will just give us a next long and so on and so forth. Okay? There is another algebra that I have, which is called key value store. Key value store has three verbs: get, put, and delete. So one more time, I have ability to lift those verbs from that algebra into our program, and I also have interpreter. And this interpreter goes from that key value store to that state object of map and key and a value, because I still need a place to store my elements, right? I still need ability to somewhere store my users or whatever I will be storing. And I'm just here having, so now you can create a program which will talk about get this, put that, delete all that, and just a program. And then we have an interpreter that will interpret that program, and as a value, it will give us just a state object. So then once, as you remember, you can run state with initial map. So we can, for example, put just an empty map to it, right? And it will, if your program was put user A, put user B, and that's all, and you will be using key value store put twice, and that's all your program is doing. And then you will interpret that program with this interpreter. It will, as an output, give you a state. And once you actually run that state with an empty map, you will end up with a map having those two users in it, inside. Okay? Makes sense? Okay, awesome. Because for me, it didn't at the beginning. So now I have those two little lower level machinery. One is monotonic sequence, just give me next long. One is key value store, put, get, and delete. And now we can do something crazy, which I once heard to be called compiling down to lower level language. So instead of having this crazy interpreter that is doing everything, so it's actually doing a business logic, like for example, creating a user account or updating age, but also dealing with all those craziness of manipulating state and all that, we can write a new interpreter. But this interpreter is doing something weird. Because instead of going from manipulate account to task or ID or whatever, as we've seen before so far, it goes down, it interprets down yet to another program. So we have our higher level language, manipulate account, the language that we use to communicate with our business, right? What does it mean to send money? What does it mean to add user or remove user or whatever the language of the business has, and then we will write an interpreter that will go to a new program. So when we actually run our program, which is built on a higher level language, what we will get after running it with our interpreter will be yet another program. So what's the point? The point is that program will be using lower level algebras, key value store, and monotonic sequence. So for example, so just to give you an example, what does it mean to create an account? Where from monotonic sequence I call next to get a new next long value, and then from key value store I call put with that handler and that user account. What does it mean to update age? Well, I call for a given handler. I fetch the user from key value store with the given handler. If the user exists, if the users exist, I will just put a modified user with the new age to the key value store, and it will update it. So at this point, I don't really know how key value store is working. I don't really know how monotonic sequence is working, because I'm interpreting from a high level language to a lower level language. Now there are few cool features about this thing. Think about it for a minute. Now, if I have this interpreter, most probably if I have like a language like a key value store, I have an interpreter for it at some point, but I only write it once. I will only write once an interpreter for key value store. I will only write once interpreter for a monotonic sequence. So then I don't have to interpret so I have business logic here, one which is responsible for manipulating accounts, right? I can interpret that to key value store and monotonic sequence, and from this program I can one more time interpret this into task, but that interpreter is already there, implemented. So if I have another business logic here, like send money or something, like manipulate, like money, like send money transfer or whatever, I can one more time interpret to a lower level language, like key value store, whatever those are, and one more time I already have somewhere there existing interpreters that would know how to deal with key value store and whatever I'm using. Just to give you an example here. So okay, so this part is a little bit weird because it's like a lot of code base. But what I'm having here is right now run one more time the same program. So my final type is something which is coproduct of input output and manipulate account. Okay, so I'm writing my little program that will just be a console application. I will ask for a name, ask for an age, and put that thing into the storage, whatever that storage is. So that's what my program is doing, and I can create my program here. And now I want to have interpreter that will go from that type EFF to my lower level language, and I have to constrain my language. So manipulate account requires for this language to actually have ability to do the key value store and monotonic sequence, while input output requires me to have ability to actually interpret itself into task. One I have right now interpreter, I will go from this to that, but that's nothing I cannot run still, right? I want to have an application where I will just have a task and I will call unsafe perform thing and the application will be running. So I right now need an interpreter that will go from this program that works on, from this language S, so with those constraints, to, for example, to task. And there's a little bit of magic here, but this is, okay, so this is not implemented for the reasons I don't remember. But basically, if it wasn't implemented, I have a lower level interpreter that goes from my lower level language, and by lower level language, so that that S is still very generic here, right? I'm saying it can be any S as long as it fulfills those three constraints. So here I'm creating a type lower EFF which fulfills those constraints. So it's actually a co-product of task, monotonic sequence, and key value store. Okay, so I'm just creating a type here that fits into this method. So now if actually I have an interpreter that will go from this type to that type to finally to task, I can at the very end create my final interpreter that I really, really need, so which is from EFF, my business logic over there, finally to a task. And it's one more time, it's since interpreters are functions, and they're not really a function, but you can think of them as functions, they have and then implemented on them. So you can say, first go from EFF to that lower level language, and then from that lower level language to task. And you have your final interpreter, and then you can finally take your program, run it with that final interpreter, which will give you a task which you can run with unsafe perform sync. Okay, make sense? A lot, I know. So, but if you really think about it, now John DeGauss, he has the whole blog post about it, like actually 2 blog posts about it, but it's actually a pretty neat idea. Because now we get with free, and with this approach, we get what we really, really strive when we write software: composition and modularity. I can now reason separate concerns, manipulate user account, input output. Those are 2 completely different things. If I had to add authentication to this program, not an issue, right? I will create yet another high-level algebra. What means to authenticate? What means to log in, log out, get some rights, whether I can actually do stuff in my application, yes or no. And now you can write your business logic. So now all those little algebras are tested independently. You have modules that work. You do whatever magic that you need to do for that this thing works. And now your user story will be a program which is composed only of those verbs that your business understands. So if they tell you actually in order to add the user into our system, you need to first log in, then you provide the name and age, and then the user should be in the system, this is how your for comprehension is going to look like. You will have a method authenticate, which will give you an option of user, right? Whether the user exists yes or not, with a list of rights. And then if that right is what you really need, then you will have another steps in your for comprehension. The for comprehension will exactly look the same way as what your business told you, what that user story was supposed to be doing. And you will have a program which you can inspect. You can see like every little steps, and it has nothing to do, that program at this point, with storage, with the language that you're going to be using will be language of, for example, user was added to a system. I'm not talking it was inserted into a storage, or even worse, inserted into Oracle database. I'm just saying, or any other, like Postgres or whatever, I'm just saying I'm not very concrete at this point of what that means. The user was added to the system. I only have a verb that is saying add user to a system. So my final solution, my final program is using this high-level algebras only. And then I will have interpreters which they will know what to do. What does it mean to authenticate? What does it mean to actually add a user to a system? You can directly say adding user to a system is actually, and you will have interpreter where add user to system will be something like a task that calls a Postgres or Oracle or JDB calls, and you add it to Oracle database. But maybe that's actually too deep. Maybe the first level would be actually to call something called storage. Have an algebra storage with functionalities like fetch, list, and all that. And then you will reason what that means to actually put the user into a system in terms of that algebra. And then you will have another interpreter that will actually know, well, storage, for example, is maybe Cassandra, right? Putting stuff in Cassandra, or maybe Postgres, or maybe other system that you want. And now you have flexibility. You can change. It's sort of like a hexagonal architecture in like people might familiar with, but it's a way new level of it. Full composability, full modularity for free. 5:20, I'm done. Thank you guys.